My name is Brian Palik. I'm a research forest ecologist with the USDA Forest Service Northern Research Station located in Grand Rapids, Minnesota. And my job is I'm a forest ecologist that kind of sits on the fence between ecology and silviculture. And most of my research focuses on what I call operational scale silvicultural experiments that are designed to address ecological approaches to forest management, but in real world settings where people are managing for timber and other forest resources. So the Adaptive Silviculture for Climate Change Project, or ASC, or ASCC, is designed to be an operational scale research experiment that provides demonstrations of climate change adaptation strategies on the ground in a managed forest setting where natural resource professionals can come and see what the issues are and what adaptation approaches might be out there for this particular forest type that we're working in. It's located on the Cutfoot experimental forest, which is on the Chippewa National Forest in northern Minnesota. The experiment itself is quite large. It encompasses about 500 acres of treatment area and then buffers and roads and so on associated with it. The treatments for the experiment were put on the ground in late winter of 2015. So the research questions really focus on the resistance resilience transition framework that Dr. Connie Millar and her colleagues laid out a number of years ago. And the questions focus on different approaches for adaptive management of red pine forests in northern Minnesota to try to move them towards being more climate change resistant or resilient in the future. The resistance treatment really focuses on more of a short-term strategy to kind of lifeboat red pine associated species into the near future. The resilience treatment, the way we've formulated, is more of a midterm strategy to increase the abundance of future climate adapted species that are currently native components of the red pine forest. And then transition treatment is a little bit more longer term, and it's designed to address the strategy to assist migration of future climate adapted species that aren't currently components of this forest type, that are more southern in their distribution, but are projected to have increased habitat suitability in northern Minnesota red pine forests in the future. We decided to implement this in a red pine dominated forest in northern Minnesota because all the projections for future climate and responses to that suggest that that forest type is potentially at risk with climate change. So major changes in species composition, potentially in pest relationships and productivity. So it was an opportunity to install these demonstrations in a vulnerable forest type. And the questions we're trying to address really are a focus on the resistance, resilience, and we call transition strategy for adaptation, where you're looking at different approaches depending on your goals and objectives and the setting you're in for adaptation. The other part of answer to that question in my mind is all the things you mentioned, insect disease, windstorms, as well as climate change, present just this environment of uncertainty to managers. And we don't exactly know what's going to happen with climate change, and we don't know exactly what's going to happen with mountain pine beetle and windstorms and other disease and insect problems. So managers need to think about managing for uncertainty. And it's inclusive of the uncertainty of climate change. It's not just that and these other things, it's the whole ball of wax together. So the idea with the ASC treatments is to present a range of options, of adaptation options that, depending on where that future goes, and given that atmosphere of uncertainty, one of those adaptation treatments is likely to be successful. And so by not doing the same thing everywhere, managers increase their opportunities to have success in the forest type they're working in, given that uncertainty of all those factors. That was a framework that was developed. The lead scientist on that is Dr. Connie Millar, who's also with the Forest Service in the West. And it was really a seminal paper that she and co-authors put out a number of years ago. And it kind of laid the groundwork for people thinking about adaptation strategies, not as just one thing, but a range of things. And one of the approaches is resistance. And it's really, in our interpretation of that, it's taking the forests that we have now and manipulating it in a way to perhaps increase the climate change resistance of the current composition and structure of that forest. In the case of red pine, it's really trying to manage density in a way that soil moisture deficits are less of a negative impact on red pine in the future with increased projected droughts in the forest type. So that's the resistance treatment. The resilience treatment, our interpretation, is really working with the native ecosystem and the range of species that are there in it, but focusing on moving that forest towards greater abundance of species that are projected to be climate change, we call them winners in the future, so more adapted to the projected future climate. In this red pine system we're working in, that would be the oak species that are there, northern red oak and bur oak, as well as eastern white pine in particular. So they're native components of the system. We feel like we're working within the natural range of variation for the ecosystem we're working in, but perhaps moving in a little bit different direction based on the species, projected species responses to future climate. And then the transition treatment is perhaps the most radical treatment of the group, but it's really more of a longer-term view of suggesting that the array of species that are in this red pine forest type now are likely to be negatively impacted by climate change over the longer term, so over the next 100 years or so. So we need to be thinking about transitioning that forest into species that perhaps are minor components of the forest now or not even within that forest type now, so the next southern climate zone, for example. So working with species to transition that forest into a different composition and structure that perhaps will be better adapted to that future climate. The resistance treatment is essentially a thinning treatment, and the motivation for that is we have some long-term data from other experiments in red pine that show that thinning to about 100 square feet of basal area allows red pine to maintain its growth during even pretty severe droughts, and if it does have a growth depression during a drought, to regain that growth to kind of a pre-drought level. And again, around 100 square feet seems to be the optimal basal area for that. The resilience treatment is more of a retention harvesting treatment where we've cut half-acre gaps throughout the forest, as well as leaving half-acre unharvested patches of forest, and then thinning in between the matrix of between the gaps in the reserve patches. And the thinning itself is about down to about 120 square feet. And then the gaps are gaps with just several large retention trees within the gaps. And the idea is to create a range of canopy conditions and environmental conditions that will favor a suite of species in that setting. And the species we're focused on are all native components of this red pine ecosystem in northern Minnesota. So it includes, as I mentioned earlier, the two native oaks, northern red oak and bur oak, as well as eastern white pine. And we're also planting jack pine within that treatment as well. It's not projected to be a climate change, necessarily responding favorably to climate change in the future, but we wanted to try to maintain that component in those larger openings, at least in the short term. And then the transition treatment is a little bit heavier of a cutting. It's also a type of retention harvest treatment, but the thinning in the matrix is to a lower level. It's more closer to about 80 square feet per acre. Again, with gaps, large gaps, half-acre gaps, and there's no reserve patches in that treatment. So it's quite a bit heavier of a treatment, but still designed to create a range of canopy conditions and environmental conditions across the stand. And the idea in that treatment, it involves planting as well as does the resilience treatment, is to look at a suite of species that are either not in that ecosystem now or really minor components, but are predicted to respond favorably to a warmer, drier climate, growing season in particular in the future. So we are looking at white oak, true white oak, Quercus alba, as a component of that system. We are also looking at a non-native pine as a potential replacement for red pine in the system. The idea there is that even 100 years from now, under a different climate, people are going to want to see a pine forest in northern Minnesota. So we try to find a pine that might be resistant or resilient to that future climate and have similar ecological characteristics and morphology as red pine. So we settled on ponderosa pine as a potential replacement for red pine in that transition treatment. Think about the three adaptation treatments as representing short-term options, mid-term options, and long-term options. So the resistance treatment is something managers can do now and gain from now. And the reason for that, it's based on already established science that shows a relationship between stand density or basal area, amount of thinning, and tree response to soil moisture deficits and droughts. We can demonstrate that works. So managers can implement that strategy right now to deal with the kind of droughts we already have periodically in northern Minnesota that are predicted to become worse into the future. So that finding, if you will, that treatment is based on established findings from related research, and it can be implemented now. The resilience treatment, which is really just creating more structural heterogeneity in that forest to create a range of conditions to allow different species that are native components of the system to establish and develop and grow, is again based on our understanding about how eastern white pine grows in canopy openings in red pine dominated forests. And we know it does well if it's given the opportunity to do it. So managers can implement those findings, those early findings, and what we're already doing, setting up in the resilience treatment to start establishing eastern white pine in their red pine forest, and have that cohort and that component there to be ready for the future, if you will. So that's established science. The transition treatment, obviously, is the one that's a little more radical and uncertain, but what it's based on is pretty well established and well accepted climate envelope models that predict changes in species habitat suitability into the future. And yes, it's modeling, and yes, there's uncertainty associated with it, but it's a pretty well established and accepted modeling approach. And what it's showing is that, for example, white oak, Quercus alba, is going to have increased habitat suitability in the range of red pine in northern Minnesota over the next 100 years. So that's one of the motivations for us planting that species in that treatment, and managers can use that kind of model prediction information to at least establish some trials of different species that they currently don't work with, but maybe just 50 miles south down the road, and are predicted to move north in terms of their habitat suitability. So depending on the treatment, there's a range of science that went into those treatments, and it's not so much we've gathered a multitude of data from the ASCC treatments already because they're brand new, but they're based on science that's there and results that managers can already implement.